This video we are going to discuss about decimation in frequency. So I am Vinod, assistant professor, EC department. So in this, let us represent x of n, a sequence of n values, where n is an integer which has a power of 2. That is, n is equal to 2 power 2. The endpoint DFT of the sequence x of n is given by x of k is equal to summation n is equal to 0 to n minus 1 x of n into wn nk, where k ranges from 0 to n minus 1. So here I am going to represent this k as 2k and 2k plus 1. So therefore I am going to reduce the k values from 0 to n minus 1 to 0 to n by 2 minus 1. So x of 2k is equal to summation n is equal to 0, n minus 1. If I substitute instead of k, I am going to replace this k by 2k. So this becomes 2k. Okay. Next I am going to replace this x as 2k plus 1. So here this will change to 2k plus 1. So this is my first equation 1a and this is my second equation 1b. So from the 1a equation, since it I'm going to split this equation into n starting from 0 to n by 2 minus 1 and n by 2 to n minus 1. If you see, suppose n value is 8, it ranges from 0 to 7. So here it ranges from 0 to 3 and this is from 4 to 7. So if I want to make this value to 0, I am going to add n with n by 2. So if I add this becomes 0. So this n becomes n plus n by 2 and here I am having n. So it becomes n plus n by 2. And so if I equate this two equation, I will get Wn of 2kn and this 2 get cancelled out. So you will get Wn of k into n by 2. So Wn of kn, Wn of k, Wn of k is written as e power minus j 2 pi k by n. Okay, 2 pi k by n. So these two get cancelled out and what is e power minus j 2 pi, this is 0. So you will get this entire statement will get cancelled out. Okay. So x of 2k is equal to summation n is equal to 0 to n by 2 minus 1 x of n plus x of n plus n by 2. This becomes 1. So you will get Wn of 2kn. So this whole term, this term I am going to write it as g of n. Okay. So and since g of n is ranging from 0 to 3, I am going to substitute n is equal to 0, 1, 2, 3. So if I substitute, you will get the g of 0 value, g of 1 value, g of 2 value and g of 3 value. So if I plot, I will get g of 0 is equal to x of 0 plus x of 4 and x of g of 1 is x of 3 plus x of 5 and g of 2 is equal to x of 2 plus 6. 3 becomes 3 plus 7. So this is what it is represented in the 1 to 4th equation. So next what I am going to do, I am going to take the 1b equation. So from the equation 1b, I am going to split this equation to n is equal to 0 to n by 2 minus 1. So this becomes n by 2 to n minus 1. So in order to make this one as 0, I am going to add n plus n by 2, and this also becomes n plus n by 2. So in order to make the limit as equal, okay. So now let us solve this equation. So if what is so this value is here, and I can take this Wn of 2nk common from these two equations, right? And these two get cancelled out. You will get e power minus j 2 pi value only. So this becomes 0. Okay. So you will get this equation. So I can also split this term as Wn of n by 2. So Wn of n by 2. How to write Wn of n by 2? That is nothing but e power minus j pi, right? So that is nothing but minus 1. So, and Wn of 2kn, I can write it as Wn by 2 of kn, right? Uh, so since this is minus, I can take this Wn of n as common. So I will get the equation like this. From this equation, I can take these two terms common, right? So I can write h of n. H of n is equal to x of n minus x of n plus n by 2. So this is also ranging from 0 to 3. So if you substitute 0 to 3, and here the n value is 8, right? So we'll get h of 0, h of 1, and h of 2, and h of 3 values. So what is h of 0? H of 0 is equal to x of 0 minus of x of 4. And h of 1 is equal to x of 1 minus x of 5. h2 is equal to x of 3 minus x of 6. h of 3 is equal to x of 3 minus x of 7. Okay. So you take this from the equation 2. So from the equation 2, you substitute again you split this equation 2. Instead of n by 2, you take it as n by 4 minus 1. So this is n by 4 to n by 2 minus 1. So in order to make it as 0, you have to add n by n plus n by 4, right? So you have to add this n plus n by 4 and n plus n by 4. So if you add, you can take this Wn of 2kn common. So what is Wn of 2k into n by 4? So this 2 get cancelled out. You will get this is as a minus 1 of k. Okay. So from this equation, right? So from this equation, I am going to substitute k is equal to 2r. So if we substitute k is equal to 2r, x of 4r is equal to this becomes 2r, and this is also becomes 2r, right? And I can write x of 4r is equal to the entire term as a of n, and it ranges from 0 to 1, right? So if we solve, you will get a of 0 is equal to g of 0 plus g of 2, and a of 1 is equal to g of 1 plus g of 3. So a of 0 is equal to g naught plus g1, g2, right? And what is a1? g1 plus G3. Now from this equation, from this equation, right? Again, you are going to substitute. Okay, so this is my equation. So from the equation G of n equation, from this equation, right? From this equation, so you're going to substitute instead of 2k, you're going to substitute 2r plus 1. Instead of k is equal to, first I have substituted k is equal to 2r, right? So here I'm going to substitute 2r plus 1, right, from the equation 5. So if I substitute, I will get, so instead of r, I'm going to substitute 2r plus 1. So let me take the fifth equation and paste it here. This is my fifth equation. So in this, if you substitute k is equal to 2r plus 1, this becomes 2r plus 1. So I can write it as minus 1 of minus 1 into 2r. And this k I am going to substitute as 2r plus 1, right? So I can write like this, right? Okay. So this entire term I am going to write it as b of m. And the b of n ranges from 0 to 1. So if you substitute, I will get b of 0 is equal to g of 0 minus g of 2. B of 1 is equal to g of 1 minus g of 3. So what is b naught? B naught is equal to g naught minus g2, and b1 is equal to into what is b1? B1 is equal to g1 minus g3. Okay. So from this equation, x of 2k plus 1 is equal to summation n is equal to 0 to n by 2 minus 1 of h of n wn power n into wn by 2 of kn. So from the equation 3a, from this equation, right? From the equation 3a, this is a 3a equation. From the equation 3a, you have to substitute instead of n is equal to 0 to n by 2 minus 1, you can write it as n by 4 minus 1 to, so the step and all, it is similar only, right? Sir. So you can see from this, I can write it as n by 2 of kn, and wn by 2 of kn is common, so I will take that one outside, and so we'll get wn of n by 4 and wn by 2 of k into n by 4. How to write wn by 2 of k into n by 4 is, so this is this w represent e power minus j 2 pi of n into kn by 4. N by this, this is 4n, right? So this 4 get cancelled, n and n get cancelled out. So e power minus j pi of k is equal to minus 1 of k. So I'm going to replace this one with minus 1 by of k, and the second write it as n plus n by 4. So the whole term So from the equation 10, so in this term I'm going to substitute k is equal to 2r. So if I substitute k is equal to 2r, this becomes 4r, and this becomes 2r, and this also becomes 2r, and this whole term I'm going to write it as C of n. So what is C of n? C of n is equal to h of n into Wn of n plus h of n plus n by 4 into Wn of n plus n by 4 into minus 1 of 2r. So n ranges from 0 to 1. So if you substitute, you will get C of 0 is equal to h of 0 W8 of 0 and h of 2 of W8 of 2, and C of 1 is equal to h of 1 into W8 of 1 plus h of 3 is equal to W8 of 3. So what is C of 0? C of 0 is equal to h of 0 into W8 of 0 plus h of 2 into W8 of 2. And what is C1? C1 is equal to W8 of 1 into h of 1 plus W8 of 3 into h of 3. And from this equation, from the equation 10, I have to substitute k is equal to 2 instead of 2r, I'm substituting 2l plus 1. So both are same. So you will get x of 4l plus 3 is equal to summation n is equal to 0 to n by 4 minus 1, and this becomes 2l minus 1, 2l plus 1, right? So I can write this becomes minus 1 of minus 1 into 2l. And now I'm going to take this whole term as d of n. So d of n is equal to this one. So if we substitute n is equal to 0, d of 0 is equal to h of 0 into W8 of 0 minus h of 2 into W8 of 2. And d of 1 is equal to h of 1 into W8 of 1 minus h of 3 into W8 of 3. So that is what I have drawn the equation. Okay. So what is d of 0? D of 0 is equal to W8 of 0 into h of 0 minus h of 2 into W8 of 2. From the equation 4, x of 4r is equal to summation n is equal to 0 to n by 4 minus 1 into a of n into Wn of 2 into 2rn. So the equation 4 is here, right? So in that one, you have to substitute r is equal to 0. So this ranges from 0 to 1, right? So the x of 0 is, this is from 0 to 1. And if we substitute, this becomes 1, right? So this becomes 0. So you will get x of 0 is equal to a of 0 plus a of 1. And if we substitute r is equal to 1, you will get x of 4 and is equal to a of 0 plus a of 1 into W8 of 4. W8 of 4 is minus. And from the equation 8, x of 4r plus 2 is equal to summation n is equal to 0 to 1 b of n. This is n by 4 minus 1, right? So it is nothing but 1. B of n into Wn by 2 of 2r plus 1 into n. So if we substitute r is equal to 0, if I substitute r is equal to 0, this becomes x of 2 equal to b of 0 plus b of 1 into W8 power 0. And if I substitute x is equal to 1, x of 6 is r is equal to 1, x of 6 is equal to v of 0 plus if this is 1 means 3, this is 6, W8 of 6, W8 of 6 is j. So instead of writing W8 of 6, I can write it as this J, I can write it as W8 of 2 also. So next from the equation 11, x of 4r plus 1 is equal to summation n is equal to 0 to 1 C of 1 Wn by 2 of 2rn. So if you substitute n is equal to 0, you will get C of n into Wn of 0. Here n value is 8, so it becomes 4 plus C of 1 into W4 of 2n, 2r. Okay. So if you substitute r is equal to 0, x of 1 is equal to C of 0, W4 of 0 plus C of 1 into W4 of 0. And the W4 of 0 and W is 1. So you will get this equation. For r is equal to 1, x of I is equal to C of 0 minus C of 1. From the equation 12, this is the equation 12. So you substitute L is equal to 0. You will get x of 3 is equal to D of 0 into W4 of 0 plus D of 1 into W4 of 1. And L is equal to 1, x of 7 is equal to D of 0 into W8 of 0 minus D1 into W8 of 2. So if I organize, I will get these are the equations which we have discussed so far. And from this, I can write x of 0 is equal to A of 0 plus A of 1. And x of 4 is equal to A of 0 minus A of 1. So what is x of 0? A of 0 plus A of 1. And x of 4 is A of 0 minus A of 1. So similarly, I can write x of 2. X of 2 is equal to B of 0 plus B of 1 into W8 of 2. So if we see x of 2, B of 0 plus W8 of 2 into B of 1. Right, what is x of 6? X of 6 is B of 0 plus B of 1 into W8 of 2. So this is B of 0 plus minus W8 of 2 into B of 1. So similarly, you have to solve it for x of 1, x of 5 and x of, we have solved this equation, and similar way we have plotted the diagram. So this is nothing but the DAF butterfly diagram.